friends, welcome to today's video. So today's question is, there are 10 pairs of socks in a cupboard from which 4 individual socks are picked at random. Find the probability that there is at least one pair. So there are 10 pairs of socks or there are 20 socks in a cupboard. Then 4 individual socks are picked up. What is the probability that there is at least one pair? So here, whenever at least questions come, you have to consider the probability of not getting even a single pair. Then for finding our answer, you have to do 1 minus probability of not getting any pair. It will be giving you the probability of getting at least one pair. So that is the first thing you have to consider here. Required probability will be, now we have to find out the probability of not getting any pair. So probability of no pair will be equal to, now let's consider in the first pick he is picking up a socks. So his probability will be 20 by 20. He can pick any of the 20 socks from the total of 20 socks, 20 by 20. Now next, how many socks will be remaining? 19 socks will be remaining. So out of this 19, how many favorable events are there? He has already picked up a socks, so 19 socks are remaining. Now he should not pick the pair corresponding to socks 1. Okay, so he has already taken socks 1. So there is a pair corresponding to socks 1. That he should not pick up. We are considering the probability of no pair. So he should not pick up socks 1 and he should not pick up the pair of socks 1. So his total favorable events will be 18. So 20 by 20 into 18 by 19 into. Now how many socks are remaining? Now he is going to pick up his third socks. So the total number of socks remaining is 18 now. But how many favorable events will be there? He has already picked up socks 1 and he has picked up socks 2. Now he should not be picking up the pair of socks 1 and also the pair of socks 2. So 4 socks have gone. Socks 1, socks 2 and the pair of socks 1 and the pair of socks 2. So only 16 favorable events will be there. The total number of socks will be 17. And out of 17, how many favorable events will be there? So now how many socks have gone? Socks 1, socks 2, socks 3. Now pair of socks 1, pair of socks 2 and pair of socks 3. So total 6 socks have gone. So the total number of favorable events here will be 14. So 20 by 20 into, you have to reduce 2 each time. So 18 by 19 into 16 by 18 into 14 by 17. Here the interesting fact is, the number of socks is only getting reduced by 1, but our favorable events will be getting reduced by 2 because our aim is to find out the probability of not getting any pair. So the pair also should not come. So 20 by 20 into 18 by 19 into 16 by 18 into 14 by 17, which will be giving you 16 into 14 divided by 19 into 17, which is equal to 224 divided by 323. So our required probability, which is at least one pair, the probability of at least one pair will be equal to 1 minus 224 divided by 323, which gives us 99 divided by 323. So this is our final answer. It's a very interesting question, a CAT level question. So practice this question. Second question, in a room there are 7 persons. Find the chance that 2 of them were born on the same day of the week. So what is the given question? There are 7 persons in a room and what is the probability that 2 of them were born on the same day of the week? So it can be Monday, Tuesday, Wednesday or Thursday or Friday, Saturday or Sunday. So 2 persons are born on the same weekday. So how many different chances are there? There are 7 days in a week. So what is the chance that 2 persons were born on the same day? So there are 2 ways in which this question can be approached. So first way is, we have to find out the probability of all the people being born on different days of the week. Then we have to do 1 minus probability that no 2 people are born on the same day. So you will be getting our answer. What is the probability that at least 2 of them were born on the same day of the week. That is the first approach. So first approach is you have to find out probability of no people on same day. So required probability will be equal to 1 minus this probability. 1 minus probability of no people on same day. So you will be getting our required probability will be equal to 1 minus, okay, no people are born on the same day. So what is the probability? So first person can be born on a Sunday. Let's tell the first person can be born on a day. Now the second person should be born on any other day other than Monday. Okay, so first person is born on a Sunday. Okay, first person is born on a Sunday. So second person can be born on any other day other than Sunday. So how many favorable events are there? 6. 6 by 7 will be his probability. He can be born on Monday, Tuesday, Wednesday, Thursday, Friday or Saturday. Now for the third person, there will be only 5 favorable events because 2 days have already been selected. So his probability will be 5 by 7. For the next person, it will be 4 by 7, then 3 by 7, then 2 by 7 and then 1 by 7. So this will be our probability that no people are born on the same day. So what will be our answer? Our answer will be like 7 raised to 7 minus 720 divided by 7 raised to 7. So that's what we will be getting. It's very difficult for computation. So we will be going for our second approach. So this is the first approach. We are just considering 1 minus probability of no people on the same day. So no people on the same day we can find out like this. Like first person can be born on any day. Now second person, he has only 6 choices. So his probability will be 6 by 7. Third person, he is having only 5 choices. So 5 by 7. Fourth person will be having only 4 choices. So 4 by 7 into 3 by 7 into 2 by 7 into 1 by 7. Now let's go to our second approach. So second approach. So let's consider the 7 persons are A to G. Now we are just considering like out of these 2 persons are born on the same day of the week. So what is the probability that 2 persons are born on the same day of the week? So how to select? So these 2 persons can be AB, AC or BC or DE or FG. Likewise it can go on. So out of these 7 persons you have to select 2 persons. So how to do that? 7 C2 ways. In 7 C2 ways you can select 2 persons out of the total 7 persons who are having the birthday on the same day of the week. Now again you have to select a day of the week. These 2 persons, let them be A and B. So this A and B can be born on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. So out of the 7 days you have to select a day. So it can be done in 7 C1 ways. Okay. So that is over. We have selected 2 persons out of the total 7 persons and we have selected 1 day out of the total 7 days. Now how many days are remaining? 6 days are remaining and 5 people are remaining. So these 5 people have to be born on 5 different days. So out of 6 days, 5 days are to be selected. It can be done in 6 C5 ways. There are only 5 people and 6 days are there. So 5 people have to be born on 5 days. So you have to select 5 days out of the total 6 days, which can be done in 6 C5 ways. Now these 5 people can be arranged on these 5 days in 5 factorial ways. Now we are selecting C, D, E, F and G. So they are born on Tuesday, Wednesday, Thursday, Friday and Saturday. Suppose that we have excluded Sunday. C can be born on Monday, D can be born on Tuesday, E can be born on Friday or C can be born on Friday, D can be born on Thursday. Likewise 5 factorial combinations will be there or 5 factorial arrangements will be there. So you have to do 6C5 into 5 factorial. So that is how 5 people will be born on 5 days of the week. Now totally there will be 7 raised to 7 ways in which 7 people can be born on 7 days of the week. So probability will be 7C2 into 7C1 into 6C5 into 5 factorial divided by total number of ways, which will be 7 raised to 7. So what you will be getting? 7C2 is equal to 7 into 3 divided by 1 into 2, which gives you 21. So 21 into 7 into 6 into 5 factorial divided by 7 raised to 7, which will be given as, this is 7 into 3. So 7 and 7 is getting cancelled. This 7 is also getting cancelled. So 18 into 5 factorial divided by 7 raised to 5, which will be giving you 2160 divided by 7 raised to 5. So that is a required probability. So you are selecting first 2 persons out of the total 7 persons. So 7C2, you are selecting 1 day out of the total 7 days in which 2 persons are sharing the same birthday. So 7C1. Now remaining 5 persons are to be distributed on the 5 days. So out of 6 days, you are selecting 5 days in 6C5 ways, and 5 people are arranged on the 5 days in 5 factorial ways. So this will be a total probability. Very important question, CAT level question. Thank you for watching.